Look, now we check the plants and the trees, they are male and female. We will start by the atoms and we will go smaller, as much smaller we can get. Now we will watch a small 1-minute video so that you understand when I speak about the atom, you understand what is the atom made of, and when I speak about it so that you understand. This is a small module of the atom, how it's made.
Although no one has yet found a way of getting a close-up view of an atom, different experiments have made it possible to build up a picture or model of what atoms consist of. The colours in these models are of course used simply to distinguish between different particles. In the centre of an atom is a nucleus. This is made up of even smaller or subatomic particles called protons and neutrons. The protons each carry a positive electrical charge. The neutrons are as heavy as protons but carry no charge. This means that overall the nucleus is positively charged, and orbiting around it are negatively charged particles.
Okay, I will explain a little so that you can understand. All the elements, matter we have, we know, are made of protons and neutrons and surrounding electrons. This is all the matter that we know are made of this. If the number of protons differ, it becomes different matter. But all the matter is made the same proton and the same neutron and the same electron. All the matter, but the number different. If the numbers are different, it becomes different metal or some gas or something. But the atoms are made from this, remember, proton, neutron, electron. This is the atom. The electron is 3,000 much smaller than the proton. Now we will speak why the electron is not flying away, it's staying with the atom. Because the proton is positively charged and the electron is negatively charged. Because of this, the electrons, they don't leave the atom, they go. This is a small idea.
Called electrons. The size of the negative charge carried by an electron is equal to the positive charge carried by a proton. Now the electrons are moving at incredible speed, in fact 3/4 of the speed of light. So what stops them shooting off in any direction? If we could pull an atom apart into its components, we'd see that a neutral atom has the same number of electrons as protons. And it's the force of attraction between the positive and negative charges that prevents the electrons escaping. Each type of atom is identified by the number of protons and electrons it has. A hydrogen atom has just one proton and one electron. An oxygen atom has 8 protons and 8 electrons. An iron atom has 26 protons and 26 electrons. But this is not enough to explain the behaviour and properties of most substances.
Okay, you took an idea about the atom, what it's made of, a proton, neutron, electron. Now we will watch a verse. And not absent from your Lord is any part of an atom's weight within the earth and within the heaven, or anything smaller than that or greater. From God is nothing hidden. In the size of an atom he's spelling, but wala asghar, not even smaller than that, it's not absent, bigger. We know this is the kind, smaller particles we know, but the bigger we don't. Now we will speak about the smaller atoms, okay, if they are positive, negative also. Now, he spoke here, smaller and bigger. It's not absent from your role. He knows everything. Even smaller than atom, the bigger. But before, in the verse, he told everything we created in pairs. Okay, we will check. If the smaller atoms, they have polarity. Now we will speak, now physics little. I will try to explain These atoms that we call proton and neutron, what are they are made of?
The idea that nucleons, that is, protons and neutrons, could be split into smaller particles was developed in the 1960s. These small particles are called quarks. The theory developed to identify 6 types or flavors of quarks.
Okay.
These were rather weirdly but memorably named.
Okay. The atoms, these protons, the atom, the protons and the neutrons are made of 6 particles, not 6, one of them, but from these particles, it's named quarks. 3 of this particle, one from this, it's made 1 atom of proton. The proton is made from this, okay? And they call this the quarks. There are 6 types.
That's up and down, charm and strange, top and bottom. 3 of these, up, charm and top, have a charge of plus 2/3, whereas down, strange and bottom have a charge of minus.
These quarks, they call it up and down, these are stable. The rest they disintegrate. And this they give charge to the proton or the neutron, make it neutral.
It's 1/3. Only 2 of the quarks are stable, and they make up all normal matter, that is,
all normal matter, the proton is made from these quarks. There is something smaller than the atom, then they are made from this.
Protons and neutrons. Hadrons are particles which are made up from quarks. Of these, baryons comprise 3 quarks and mesons 2.
Look, this is the proton. It made from 2 up quarks, 1 down quarks. And the neutron is made 2 down quarks, 1 up quark. These atoms, the inside, it's made from quarks also, smaller particle.
A group of particles called baryons, of which protons and neutrons are the most significant members, are composed of 3 quarks. The proton, 1 down and 2 up quarks, and the neutron, 2 down and 1 up quark. The charges on these quarks comprise the total charge of each of the nucleons. For instance, a proton is made from 2 up quarks, charged 2/3, and 1 down quark, charged minus 1/3. The total charge is therefore 1. A neutron is 2 down and 1 up quark, and those charges cancel out to 0, that is 2/3 minus 1/3 minus 1/3. I started by saying there are 6 quarks, but in fact,
Look, listen well here.
there are 12, because each quark has an antiparticle.
You heard that? The protons and the neutrons are made of quarks. 6 quarks. But there is anti-quarks also, 6 anti. The verse is correct. Even this word, when it's he told everything in pairs, even the quark has a pair. There is 6 quarks and there is 6 anti-quarks. Let us continue.
An anti-up, an anti-down, and so on. Therefore, there are 12 in total. None of the anti-quarks are stable. Mesons are unstable particles consisting...
Look, we told the atom are made of 3 quarks, okay? This is another kind of atom. It's made of 2 quarks, but it's not stable. It disintegrates. The normal matter we know, the proton inside is made of 3 quarks. We don't know anything else. This is the biggest.
Of a quark and an anti-quark. An example of this is the pi meson or pion, which has an up quark and a down anti-quark. The strange quark was so called because the mesons that included it had a strangely long life. Only about a nanosecond, but long.
You see, they are not stable. 1 nanosecond. It's 2 quarks, but it's like 1 second. But the matter, billions of years. The 3 quarks are stable.
Of the mesons. For the last of our examples, this particle, the negative chaos, consists of a strange quark and an anti-up quark. So far as we're concerned, the most important lepton is the electron.
Now we spoke about the quarks that make up the protons and the neutrons. Now we will speak, they tell leptons, types of electrons. There is 6 types, electron 3 types, and neutrino 3 types. This group is called leptons.
But there are 2 others, the Mu and the Tau. Or if we count the associated neutrinos, there are 6 leptons.
Look, remember this tau neutrino, okay? We will speak about this particle too much. This is the electron smaller than the atom 3,000 times, and the tau neutrino is smaller than light. It's smaller than the light. We will speak about this too much.
Electron-like particles and neutrinos exist as a weak doublet. The pairing is sometimes likened to a dog with a flea. Unlike fleas, neutrinos can exist separately. The electron with its neutrino is part of all normal matter.
All normal matter outside the atom, they have electron, they are stable. These 2, they are stable, they tell you. These other electrons, they disintegrate.
And these are stable particles, although in fact all the neutrinos are stable.
Okay, even the neutrinos are stable. Remember this, okay? The smallest particle is stable. We will speak about this. This is a big subject, this is. The small tau neutrino.
Whereas the charged Mu and Tau are not. We said there were 6 leptons, or perhaps 3, but in fact we can count 12, because every part
we have 6 leptons. They have the antiparticles also.
Has its antiparticle.
You see, even the smallest particle, the light, has its own antiparticle. The verse said, everything we make in pairs. Even the light, the neutrino, has its antiparticle, antineutrino. Till now, we are walking.
The antimatter electron is called the positron, and it is also stable, unless of course it collides with its counterpart, the electron. If a particle collides with its corresponding antimatter particle, then they will annihilate. The resulting...
You understand this? If positive electron and negative electron, they hit each other, they annihilate, and they give light gamma rays. You know this, like lightning.
Pulse of energy may be emitted as photons or converted into other particles. Notes supporting this video are available on the website. Thank you for watching.
For free